All right, so today we are going to go through a double replacement reaction and then a couple single replacement reactions to go through our rules and when they occur versus when they don't occur and what they look like. So the first one we have is sodium sulfate. So we know that this one is going to be a double replacement reaction because we have a compound reacting with the compound. The first thing we need to do is we need to figure out our states of matter and we need to figure out, does the reaction occur? So we're going to write, and I recommend writing your ions out. So we're going to write Ba is +2, Cl is -1, sodium is +1, and sulfate is SO4 -2. So let's write our formulas. So we have BaCl2. We're going to look at our solubility chart, and if we go up here and we look at our chlorine rule, that is soluble, and barium is not an exception. So that means that this is going to be aqueous. Then we're going to react it with sodium sulfate, which this is a 1 charge, this is a 2, so it's Na2SO4. We know that this is also going to be aqueous because it has a group 1 metal. Those are always aqueous. Now we need to figure out our products. So both reactants can always be aqueous. However, if both products are aqueous, that means they all dissolve in ions and nothing is going to happen because the aqueous means when you put it in water, it dissolves and breaks apart into ions. So let's look at what goes with what. So barium is positive. It's a cation, so it has to go with an anion, which is negative. So it is going to create BaSO4. Now remember, they're both 2 charges, so they cancel out. And then we have to figure out our second compound, which is going to be the sodium is going to form with the chlorine, and that's going to create sodium chloride. We know this one's automatically aqueous because it has a group 1 metal. So now what we have to do is we have to look at the barium sulfate. So let's go find sulfates up here. We find sulfate is group 5. Barium, so it says it's soluble. However, if it's with barium, it makes it the opposite. So that means that this is a solid. So since we have a solid and both products are not aqueous, a reaction takes place. So we want to go ahead and balance it. We just put a 2 in front of the NaCl, and now we're balanced. So now we're going to draw them. So we're going to draw our first reactant, which is the barium. So I'm going to draw a box to show my beaker. So in order for it to dissolve, we have to put water. So I'm going to add some water here to show that we have an aqueous solution. Aqueous means dissolved in water. So now, because this is aqueous, it dissolves and breaks into ions. So that means we will get 1 Ba for every 2 chlorines. And that's what our first beaker would look like. Then we have our second beaker, again, is going to have that water in it. But this time, we're looking at our second product, which is the Na2. We'd have 2 Nas. So we're going to have 2 Nas. Do this color. So Na +1, Na +1. And then we're going to have 1 SO4 negative. And now we're going to draw our product. So in the end, barium sulfate is going to stay a solid. So we can just write barium sulfate down there. So just leave it as BaSO4, showing that it's at the bottom, condensed, so have small particles close together. NaCl is going to dissociate, which means that we're going to, again, still have water in this beaker. And all that's left is that we'd have 2 Nas, which is good because we started with 2 Nas. We had 2 Nas. And we'd have 2 Cls because we balanced this, so it'd be Cl, which again is good because we started with 2 Cls. So that's how you would do it for a double replacement. Now remember, if both of these are aqueous, that would mean no reactant. So if you have aqueous plus aqueous on the product side, this would be no reaction. Single replacement, those are a little different. So single replacement, those we are going to use the activity series. Because in a single replacement, we have 2 cations or 2 anions that are fighting for the other cation or anion. So the first example that we're going to do is going to be magnesium plus lithium sulfide. So we're going to do Li2S. Okay, magnesium we know is a metal or a solid. So now we're going to look at lithium sulfide, group 1 metal. Okay, we know that that's aqueous. So let's go up to our activity series. We're going to write our ions. So we know we have Mg is +2, Li is +1, and then S is -2. Looking here, we have 1 negative that two of these positives are fighting for. So both magnesium and lithium want this sulfur. We need to figure out who is stronger and who is going to win the battle. So let's go to our activity series. We see lithium's up here. So lithium is very reactive. Magnesium's here, so it's a little less reactive. So this one is stronger, meaning it is going to win the fight. So let's go here. All right, well, lithium is already in the compound, so this one is the stronger one. This one is the weaker. The weaker one cannot kick out the stronger one, which means that this one is going to have no reaction. We're going to draw this to show. So we're going to draw a beaker here and a beaker here to show the both and then the product. So magnesium, we would draw as a solid. Lithium sulfide, because it has a group 1 metal, is going to be ionic or aqueous, which means it's going to dissolve in water. It would break into 2 lithiums and 1 sulfur. And now we'd look at our product, and since nothing's going to happen, we'd end up having magnesium still there. So this is still magnesium. And then we'd end up having water, and then we'd have the lithium and the sulfur. So it'll look exactly like these two combined. So that shows us it's no reaction. So let's try another one. So now let's say we have zinc, which is a solid, plus AgNO3. These are always soluble, so nitrates are always soluble, so this would be aqueous. All right, so now let's look at our ions. So Zn is +2, Ag is always +1, NO3 -1. So we have 2 positives fighting for this 1 negative. So we need to see who's going to win, zinc or silver. So let's go up here and we look up zinc and we look up silver. So here's silver down there, here's zinc. So zinc this time is the stronger one. So we go here, this is the stronger and this is the weaker. So this time zinc is going to kick out the weaker one. So silver gets the boot and is going to be by itself. It's a solid. And then what's left is going to be zinc with a +2 charge, nitrate with a -1. So it'd be ZnNO3 2. Nitrates are always aqueous, so this would be aqueous. All right, so now we're going to draw this. So zinc is a solid, so I'm going to draw zinc, so that's Zn, plus AgNO3 is aqueous. But let's balance this to make sure we don't need to draw a certain amount. So we actually will need to put a 2 here and a 2 there. So now I'm going to draw 2 Ags. So I'm going to put my water here. Okay, so there's some water. Now I'm going to put 2 Ags with a +1. And I'm going to draw 2 NO3s with a -1. All right, now we're going to make our product. So we're going to make 1 product beaker because they all end up getting combined. So I'm going to put my water here. All right, so this time, silver is our solid. So I'm going to draw the silver in the bottom. And this time, the zinc and the nitrate are going to be in the ion form. So Zn would be a +2 charge. There's only 1 of them. And then NO3, we'd end up drawing 2 of them because it has NO3 too. And this is what this beaker would look like. So you'll notice what we started with and what we ended with are different substances. And so this shows us that a reaction would take place.